15 divided by 5. Now we've already touched on this idea of divide a little bit. We mentioned it when we were talking about using the hundreds, tens and units grid to multiply and divide by 10, 100 and 1,000. The difficulty with divide, or the first difficulty with divide, is that there are lots of different ways to read and interpret the question, to explain what divides are and what we mean when we're using them. The first one is the one we've already seen, and that's the idea that if timesing is making something bigger, it's grouping things together to usually make them bigger, then dividing is the opposite, it's making it smaller. When we were using the hundreds, tens and units grid, we were moving numbers up the grid to make them bigger, to times them up into larger place values. We were moving them down the grid to reduce their place value, and we were dividing. 1 jump for 10, 2 for 100, 3 for 1,000. So the first way to interpret a divide is as making something smaller. Now this comes with its own problem because not always will this be the case. We will see later where that might fall down a little bit, but a lot of the time dividing will be about making things smaller, or at least cutting them up. We can also think of the divide, perhaps more usefully than in terms of making things smaller, as being the opposite to timesing. In much the same way that adding and taking are sort of opposites of each other. Adding is moving up a number line, taking away is moving down a number line. Timesing and dividing are sort of opposites of the same thing. Timesing making something bigger, dividing making it smaller. Again, we saw that with the hundreds, tens and units grid. Again, there's slightly more nuance to it than that. It's a little bit more in depth than that, but broadly speaking, they are opposites of each other. Now, the next way to interpret a divide is the one that you're probably most familiar with. And that's the idea of a divide as a share in some way. 15 divided by 5, 15 shared among 5, shared equally into 5 groups, if you like. It could be something with some context, like 15 pounds shared among 5 people. It could be 15 people split across 5 different rooms. It doesn't matter. It's 15 somethings shared into 5 equally sized groups. Like Lego bricks, for example. I have 15 Lego bricks here and I'm going to share them equally into 5 equal piles. At this point we will generate an answer to this question. It's worth doing that now because we can come back to that later. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have shared those bricks into 5 equal groups. In each group there are 3 bricks, so what is 15 shared among 5? 15 divided by 5 is, in fact, 3. So I could write equal 3, and we're going to refer to that again in a minute. 15 divided by 5 is 3. Now the final way to interpret the divide is the how many. So what this says, yes, it's 15 divided by 5, it's 15 shared by 5, or take 15 and make it 5 times smaller, but it's also how many of this are there in this? How many 5s are there in 15? As in, if we counted up in 5s, how many would we need until we got to 15? So in this case, how many 5s in 15? Now you can probably see where this is going, but I'm going to illustrate this again with the bricks. 1, 2, 3, 4, 5. One lot of 5. One, 2, 3, 4, 5. 2 lots of 5. And then 1, 2, 3, 4, 5 remaining. That's 3 lots of 5. How many 5s are there in 15? 3. And look at that, it's the same as the answer we got there. So both of these two interpretations of the divide work to give us the same answer. Now we should probably check that these definitions are valid as well. We know that these two seem to at least work together. That suggests that they are both valid. They give us the same answer after all. Let's have a look at this one, this idea of making something smaller. We're saying here we are taking 15, we're making it 5 times smaller. Now if that generates the answer 3, then we're okay, and that works as a valid definition as well. Well, it's difficult to work out how to make 15 5 times smaller, but certainly we could think of it the other way around. We could say if we take 3 and make 3 5 times bigger, if we get to 15, then it must be the case that starting at 15, making it 5 times smaller, will generate 3. Doing it the opposite way round. 15 is quite difficult to make 5 times smaller, unless we obviously recognise that that is a proper way of doing it. But if we make 3 5 times bigger and we get 15, then we're okay. 3, making it 5 times bigger, well surely that is just doing 3 times 5. We're making it 5 times bigger. And 3 times 5, 5, 10, 15 is indeed 15. So this works as a definition as well. This idea of making it smaller, because doing the reverse takes us back to where we started. And in fact, doing the reverse means we've also done the opposite to times. So all 4 definitions hold. Which of these is the best one? Well, it's always worth bearing that in mind, because there will be cases where we might want to check stuff by doing the opposite. If you want to check a divide, you could always times to check it. And there will be cases where we're using that opposite as part of other questions. This is worth bearing in mind, but again, it comes with its warning that it's not necessarily going to be true in all cases. These two are probably the most useful, and we'll switch between them depending on the question. Some questions it's going to be easier to think of things as a share, and some questions it's going to be easier to think of things as a how many. In fact, the how many is the one we're going to focus on for a method, because divides related to the times tables, and let's be honest, this one is one, are probably easy enough to work with, because you either recognise your times tables and could just write down the answer straight away, or you could do a little bit of counting up. We could have used this one, counted up in 5s and got to 15 fairly quickly. They're small enough numbers, but we need a method that will work for any divide question at all. The thing that makes divides really difficult, particularly the larger numbers, is this bus stop or bus shelter method. This idea that we've got the start total on the inside, and we've got the number we're dividing by on the outside. And as soon as people see that, they tend to panic, because it turns it into something quite complicated. It is definitely a divide with a capital D. So we're not going to use that. Now, obviously this comes with the advice that if you can do this and you want to stick with it, then fine. But if you really can't and you know that you hate it, I don't like the look of this either. I choose not to do divides with these. They're alright for some, but it's a rare person I've met who is happy doing divides in this way. So we're going to find a different way of doing it. I have here 30 Lego bricks, and what I'm going to do is I'm going to use them to help me work out an answer to the question 30 divided by 2. Now again, there are different ways we can read that divide. We could read that as share 30 into 2 equal piles, or we could read that as how many 2's are there in 30, and that's the one I'm going to focus on. Now I suspect that most of you can probably work out what 30 divided by 2 is without needing to use counters, something physical, to work it out with. And that's fine. If you have an answer in mind, keep it in mind. When we then see it turn up, we'll know that this method works and we can apply it to questions where we might actually need to use this. This is a reasonably simple one, and I've chosen this very deliberately because it's simple, so that we can work out a method that we can use for any divide question. In particular, bigger numbers or more complicated things to divide by. Dividing by 2 is not that difficult, but if we were dividing by, say, 7 or 9 or something like that, it might be useful to have a method that will work any time. Now I'm going to focus on the how many definition of the divide. I'm going to work out how many 2's there are in 30. Now to do that, what I'm going to do is I'm going to say, well, I could take these 2 out and put them to one side, and there's definitely 1 2 in 30, because there it is. But there are some left. Well, that's fair enough. I could take another 2 out and put that to one side. So there's 2 and there's another 2. So there's at least 2 2's in 30. So the answer is at least 2. But there's still some left. So I could take another 2 out. There's at least 3 2's in 30. But there's still some left. So I could take another 2 out. And another 2. 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 Another 2. Another 2. And then a final 2 there. And what I'm doing is I'm repeatedly taking away 2. I took away 2, I recognised that there was some left, and I could do it again. I took away 2, there was some left, I could do it again. I took away 2, there was some left, I could do it again, and so on. And I kept going until I hit 0. Why did it make sense that I could do that? Well, think about how we talked about divide being the opposite of times. And we said that times, at its most basic, was just repeatedly adding on copies of the same number until we had a certain number of them in total. Well, if timesing is repeatedly adding, then surely divide, as the opposite, would just be repeatedly taking away. Keep taking away the same amount until we hit a point where we either can't do any more or we've got to 0. We've got rid of everything. And that's exactly what we've done here. We've continuously taken away 2 until we hit 0. And how many times could we do that? Well, we did it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. So our answer to the question 30 divided by 2 must be 15. Because there are 15 lots of 2 in 30. And again, we obtain that number by repeatedly taking away 2 until we hit 0. Now that as a method, as an approach to divide questions will work perfectly fine for any question. Just keep taking away the number you're dividing by until you haven't got any left. And count up how many times you've taken it away. Because how many times you've taken it away is how many there must have been in that total in the first place. The problem is that took a while. And they were fairly simple numbers. 30 is not that many. But because 2 is quite a small number and 30 is much bigger comparatively, it could take a while. And if you were trying to divide a hundreds number or even a thousands number by something, it would take a long time. And you wouldn't have the advantage of a physical prop, counters or bricks or whatever, to use. So maybe we need to refine this a little bit more. Maybe we need to hone it in to be something a bit more useful. Okay, let's go back again. Well, maybe we could take some shortcuts. Maybe rather than take just 2 out, maybe we could be a bit clever about it. Maybe we could say, all right, then, well, what about, maybe I'll take 4 out at a time. Why would that be useful? What do we know about 4 in relation to 2? Well, we know that in this pile of 4 here, there are 2 groups of 2. There are 2 2's in this. So there are 2 2's in there. I could take another 4 out. And there's another 2 groups of 2 in there. We could take another 4 out. And there's another 2 in there. We could take another 4 out. And there's another 2 in there. Another 4. And there's another 2. And then another 4, and there's another 2, and then another 4, and there's another 2 groups of 2, and then we've just got a 2 left. So there's just one group of 2 there. So how many 2's are there in 30? Well, there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got the same answer. And we've done very much the same thing, but rather than take away 2 repeatedly, we've taken away 4. Until we got to a point where we couldn't do it anymore, and then we just took away a 2. Because we used the fact that we know, from times tables maybe, from counting up on our fingers perhaps, that 2 2's will make 4, and we took away chunks of 2 instead of just 2 on its own. But let's consider the same idea again, and this time get really clever, because that was quicker. It was quicker to be taking away 4's. We got down to a point where we couldn't do that anymore. We got down to 0 much quicker. We can get really clever with this, though, and we can try and do exactly this method in the simplest way possible. Let's think of a really easy to obtain fact based around 2 that will let us take a big chunk out in one go. A really easy fact that we know that 10 lots of 2 is 20. So why don't we take 20 out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And what's the advantage of doing that? Well, because we know in that 20 there are 10 lots of 2. And then I guess we could take away a lot of 2, and another one, and another one, and another one, and another one. And altogether we've taken away 10, 11, 12, 13, 14, 15 lots of 2, and we've got the same answer, because we're just taking away chunks of 2 instead. We could even get clever here, and rather than taking away single lots of 2, we could take away, say, 4s, and have it be 2 there, 2 there, and 1 here. Take out the 10, take out a pair of 2s, another pair of 2s, and then have a single 2 left over. 10, 11, 12, 13, 14, 15, and get clever about it. We might even be really clever and recognise that there are, if we've taken out 20, 10 pairs, we might even recognise that there must be 10 left. And we might spot that 10 is 5 lots of 2. 10 lots and 5 lots, 15 lots of 2. Whichever way we look at it, 15. Now that we have a bit of a method, let's see if we can firm this up into something we can use every time. A standard set of steps that we can follow. And we'll come back to that question that we mentioned briefly before. 204 divided by 6. Now what this question says is either start with 204 and share it into 6 equal piles. Could be 204 pounds, could be 204 people, it doesn't matter, it could be anything. Or it says how many 6s are there in 204. They will both obtain the same answer because they're both valid definitions and different ways of reading the divide. We're going to focus on that second one, and we're going to use what we've just done with the bricks, but we're going to build it up into a proper method. So the very first thing we're going to do is we're going to set up what we're going to call a bank of key facts. We're going to have our key facts. I'm going to box them off over here so that we can keep them nice and neat. And I'm going to set up some key facts. And they are going to be key facts about the number that we are dividing by. So in this case, they're going to be key facts about the 6. If we're dividing by 7, we do key facts about 7. If we're dividing by 9, we do key facts about 9, and so on. And the key facts I'm going to work out, I'm going to write down 1 times 6, because that's easy enough to work out. I'm going to do 2 times 6, because that's easy enough to work out as well. I'm going to do 10 times 6, because that's easy enough to work out. We can think about the hundreds, tens, and units grid. This is a reasonably simple one. We could probably just write the answer to that down. And we could use that one to find 5 times 6. And these are the 4 key facts that I'm going to write down. So 1 times 6 is, of course, 6. 2 times 6, 12. 10 times 6 is 60. And 5 times 6, well, half of the 10 lots will be 30. And they are my key facts. 6, 12, 30, and 60. Now what I'm going to do is I'm going to start with the 204. And I'm going to take away chunks of 6 using my key facts to help me. I'm going to take away chunks of 6, a little bit like we did with the bricks before, but in a slightly more organised way. So I'm going to number these because I'm going to do a series of sums. I'm going to number them so that we can keep it nice and organised as to what I'm doing. I'm going to set it out nice and neatly as well. I'm going to start with the 204. I'm then going to look at my bank of key facts and I'm going to choose the biggest number from the purple ones, the 6, the 12, the 30 and the 60, the answers to the key facts. I'm going to choose the biggest one that I can take away from the 204 and still have something left. And the biggest one, of course, is 60. So I'm going to take away the 60. Now you can do this how you like. I'm going to set this out in columns so it's nice and clear what I'm doing. But I'm going to do 204 take away the 60. If you want to work it out in your head or just write down the answer, that's absolutely fine. But as long as you keep track of what you're doing, I'm going to do it in columns to make sure I get the right answer. So I'm going to start with units. 4 units take away 0 is just 4 units. 0 tens take away 6 tens. I haven't got enough tens in the first bit. Problem, we haven't got enough tens. Solution, find some from somewhere. So I'm going to look at the hundreds. I don't need both of those hundreds, so I'm going to keep one of them and I'm going to swap the other one for some tens. I'm going to swap it for 10 tens, so we've gone from having 0 tens to 10 tens. 10 tens take away 6 tens, 4 tens. And then 100 take away no hundreds is 100. So I started with 204, I took away 60 and I'm left with 144. But I know that I definitely took out how many lots of 6? Well, I took out 10 lots. So underneath, I'm going to write that down. I'm going to say that I took 10 lots away. So there are definitely at least 10 lots of 6 in 204. But there's still some left. I'm on 144. So I could do another takeaway. I could start with 144 this time. I can look at my bank of key facts and choose the biggest number that I can take away. Now I can use these more than once. They're just key facts. Once I've used it, I can use it again. That's absolutely fine. And I can look at my bank of key facts and clearly the biggest thing that I could take away is, once again, 60. So I'm going to take the 60 away. I'm going to do it again as another column subtraction. 4 units take 0 is another 4. 4 tens take 6 tens. Can't do it again. So I'm going to have to swap that 100 there for 10 tens. And I've now got 14 tens. 14 tens take 6 tens is 8 tens. And then 0 hundreds take 0 hundreds. Leaves me with 0. So just 84. And that is another 10 lots that we've taken away because I took away 60 and 60 is 10 times 6. So that's 10 lots gone. We've still got some stuff left, so I'm going to look at my key facts and I'm going to choose another chunk of 6 to take away. We could set up a third sum then. I've got 84 at this point. Look at my bank of key facts. I could take another 60 away. I'm using it 3 times, but that's absolutely fine because I'm taking away the biggest chunk of 6s each time. 84, take away the 60. Well, 4 units take 0 is 4 units. 8 tens take 6 tens, 2 tens. And again, I've taken away 10 lots. Still got some stuff left, so I could set up sum number 4. 24. Now I need to look at my key facts and choose the biggest chunk that I can take away. Can't take away 60 this time, I haven't got enough. And I can't take away the 30 because I've not got enough either. But I could take away a 12. So I'm going to do that. I'm going to do 24, take away a 12. 4 units take 2 units is 2, and 2 tens take 1 10 is 1 10. And I have taken away this time 2 lots. I've still got some stuff left, so I can do another sum. We should be able to finish it off with this one. We're on 12. We could take away another 12. That will take me down to 0. I've hit 0. That's the point at which I can stop taking stuff away because all of it has been accounted for. 2 lots in there. How many lots of 6 did we take away? We took away 10, 20, 30, 31, 32, 33, 34. So we reckon then our answer is 34. We have the advantage of a calculator, so we could check that on our calculator if we wanted to, just at the moment. If we do, on our calculator, 204 divided by 6 equals 34. Look at that. If we didn't have the advantage of a calculator, we could also check it. We could do, well, we reckon that 34 lots of 6 give us 204, so we could work that out. We could just off to the side somewhere work out 34 times 6, however we want to work it out. 6 lots of 34, 34 lots of 6, we should get 204 as well. We'll do another example just to hammer this home. 432 divided by 9. So the question we're asking is either 432 shared equally into 9 groups or piles, or how many 9s are there in 432? And that's the focus we're going to have. First step with any of these questions, we're going to box off a bank of key facts. And this time we're going to be writing key facts about 9. Why? Because 9 is what we're dividing by. So we need to know information about 9 and chunks of 9. I am going to choose to do 1 lot of 9, 2 lots of 9, 5 lots of 9, and 10 lots of 9. Why? Because they are all reasonably easy to work out. 1 9, 9. 2 9s are 18, 10 9s are 90, and 5 9s, half of the 90 would be 45. So we've set up our bank of key facts. Much like we did in the previous example, we need to start with the 432 then. So our first sum, 432. I'm going to look at my bank of key facts and I'm going to look at the orange numbers, 9, 18, 45 and 90. I'm going to choose the biggest one that I can take away from the 432. And the biggest one that I can take away is the 90. So I'm going to do that. I'm going to do 432, take away 90. Again, I'm going to set it up in my columns. That's personal preference, whether you want to or not, as long as you get the right answer. 2 take 0 is 2. 3 tens take 9 tens we can't do, so I'm going to swap one of those hundreds for 10 tens and have 13 tens. 13 take the 9, leaves me with 4 tens, and then 3 hundreds take 0 hundreds is 3 hundreds. And we need to make a note of how many we've taken away. Well, we've taken away 10 lots, because 10 nines were 90. That's where that fact came from. We've still got some stuff left. We've got 342, so I'm going to do a second sum and start with 342 this time. We're always carrying that total to be the start point of our next sum. I'm going to look at the key facts again. Again, we could take 90 away. So let's do that. Which will leave me with 252. And again, we've taken away 10 lots. We've still got some stuff left. We could in fact take another 90 away, so let's do that. $252, take away another 90. Another 10 lots gone. We've still got some stuff left. It's a little bit longer, this one, but the subtracts are not taking that much time, really. We could do 162. We could take another 90 away. Again. And we're down at 72. That's another 10 lots gone. Now, at this point, this is where we start to have to look more closely at the key facts, because we've still got some stuff left. We've got 72 remaining. But we can't take away 90 this time because we've only got 72, so we have to look at our key facts. We could, in fact, though, take away 45. We could do 72, and then we could take away 45, because that's the biggest thing in our bank of key facts that we could take away. So 72, take away the 45. Leaves me with 27, and that's 5 lots gone. We've still got some stuff left. So sum number 6, 27. We could take away 18 this time. We've still got some stuff left. So 27. We could take away 18 this time. Which will leave me with simply 9. That's 2 lots gone. And then our final sum, nice and easy, just to make the point that this is what we have to do. We could take away a single lot of 9. We'll end up at 0. We've got rid of everything. We've used all of the 9s that we can. That's 1 lot gone. Final thing we need to do, count up how many lots we got rid of in total. That's 10, 20, 30, 40, 45, 46, 47, 48. And we reckon then that the answer is going to be 48. And again, with the advantage of a calculator, we could always check that. If we didn't have a calculator, we could check it by doing 48 times 9 and working that out somehow, perhaps off to the side with our grid, with the diagonals in maybe. But if on our calculator, 432 divided by 9 is in fact 48. Now, where this method might fall down is that it's not necessarily the quickest thing in the world to do. It depends how many subtracts you have to do. But if you really don't like divides, and in particular if you don't like the bus stop type method, this is a good thing to do. You can speed this up. First of all, by making sure that you are good enough at subtracts that you can do them like that quickly. The second thing you could do to speed it up is you could adapt the bank of key facts. I've suggested that 1 times, 2 times, 5 times, and 10 times are all you really need. And in fact, that is true. It tends to be that with most questions, they will do. They are perfectly reasonable. They're easy enough to find. They're a good balance between being easy to find and being useful. But you may want to adapt this yourself. You might find that actually, as you're doing questions, you think, you know what? 20 times would be useful. And 20 times would be easy enough to find because you could just double the 10 times. If we're already halving it to get 5 times, you could always double it to get 20 times if you feel it's something you want to do. It might be that you end up doing that for all questions. It might be that you end up doing it for some questions. It might be that you never do it. Something that would probably be quite useful to do though for some questions, particularly if the starting number is very big, you could always work out 100 times. If you're already working out 10 times, 100 times would not be too difficult a thing to do. And if you're working out 100 times, I guess you could always start getting a bit fancy with it. You could always work out, say, 200 times by doubling it, or 50 times by halving it. They would be okay. But that's sort of personal preference. This one is quite useful for some things, 100 times, or maybe even 1,000 times if it's a very big number. That would be okay. And you're just sort of adapting what you're already doing with the bank of key facts. This one's more of a personal preference thing. It might be that you even start to add things like 3 times. When we got down to the 27 before, you might have noticed that 27 was 3 lots of 9, in which case if you'd had 3 times in your bank of key facts, you could have just taken away the 27 and got down to 0 that way. It's a little bit of personal preference. 1, 2, 5 and 10 will do, sometimes needing to add 100 or 1,000 if they're very big numbers, but you could also start to add in your own choices as well. We'll do one more example, and it's just to show that you can actually use this method with decimals if you are very careful. Something like 12 divided by 0.5. Little bit trickier. It is a little bit trickier, but we could still do this in the same way. We could set up our bank of key facts. I mean, okay, yeah, we're dealing with a decimal, and okay, we're setting up a key fact box about decimals, but that's all right. We could still do 1 times, 2 times, 5 times, and 10 times. Well, it's 1 times 0.5, 2 times 0.5, 5 times 0.5, and 10 times 0.5. Some of these will be easier to fill in than others. Well, 1 times 0.5, easy enough, 0.5. 10 times 0.5, right, 0.5 starts in our hundreds, tens, and units grid. Everything shifts 1 place up. And if we start with the 0.5, you can do this for yourselves if you want to check it. The 5 will move from the tenths across that decimal point into the units. And we will end up with 5. 2 times and 5 times. Well, 5 times is then easy enough to work out. Half of 5. This is where it starts to get tricky. But this is where we could actually use this space just quickly to work out some of these. Rather than think of it as 2 times 0.5, or even 5 times 0.5, or even 10 times 0.5. To be honest, we could prove this point. Why don't we use that little trick of turning them into money? Shove a pound sign in front of there. They look a bit weird because we've only got 1 number after the decimal point. Well, we could add an extra one in and do this. And suddenly, it's 2 times 50p, 5 times 50p, and 10 times 50p. Well, 2 times 50p would simply be £1. 10 times 50p would be £5. That's what we got before. And 5 times 50p would be half of £5, £2.50. And there are our answers for the key facts. 2 times 0.5, if 2 times £0 and 50 pence is £1, 2 times 0.5 must be 1. And the 5 times 0.5, well, if 5 times 50 pence is £2.50, we must have 2.5. So we filled in our bank of key facts. It was a little bit harder to do maybe, but we can always fall back on that idea that decimals are just money. Now that we've got our bank of key facts though, the question works like any other. So we start off, first step, we start with the 12. And we look at our bank of key facts and choose the biggest number that we can subtract from the 12. Well, that happens to be the 5. So we could do 12 take away 5. Which was 10 lots. We've got some stuff left, so we could do another subtract. We could start with the 7, and we could take away, well, we could take away another 5. That's okay to do. And we're left with 2. And that was another 10 lots. From that point then, we could do a third sum. We could start with 2. We could take away, we can't take away 5, we can't take away 2, we could take away 1. We could take away 1, and that leaves me simply with 1. That was 2 lots gone. And we've got one more sum that we could do to hit the 0. We could start with 1, we could take away a 1, that leaves me nicely with 0, and that was another 2 lots gone. So this question, 12 divided by 0.5, 12 shared between 0.5 people, piles, groups, doesn't really make sense. But thinking about that question in terms of the how many 0.5s are there in 12? Well, that's 10, 20, 22, 24. 12 divided by 0.5 is 24. And you might well be looking at that and thinking that looks really weird, because surely when we divide, things get smaller. We're splitting stuff up, we're cutting it up into chunks, we're grouping it out. Surely things get smaller. And this is where that old kind of misconception comes from. Generally speaking, when we're dealing with divides, yes, things get smaller, and I did talk about that as a definition. When we times, things generally get bigger. When we divide, things generally get smaller. But that's only really true if we're dealing with whole numbers. Once we start putting decimals in, some things can go a little bit funny. 12 divided by 0.5 is 24. It seems to be right because it worked for the method. Hopefully the method isn't wrong, because if the method falls apart, we haven't actually got anything we can use, and we've wasted our time in this video. The method is right, I am telling you that. So that means that 24 is the answer. But it just looks really weird, because how can we have more than there are? Well, it's because you're forgetting that it's a decimal. Now, to deal with decimals, we said we can help ourselves understand them by treating them like money. Let's put some pound signs in. 12 pounds divided by 50 pence. Now that question is now, how many 50 pences are there in 12 pounds? How many 0.5s are there in 12? How many 50 pences are there in 12 pounds? Well, for each £1, there are 2 50 pences. So there's 2 50 pences in the first pound, 2 in the second, 2 in the third, 2 in the fourth, 2 in the fifth, and so on. There are 12 pounds in total, and I would have to swap that for 24 50 pences. So that's why 12 divided by 0.5 is 24, because you need 2 50 pences for each pound. We've got 12 pounds in total. That's 12 lots of 2 50 pences is 24 50 pences.